Hello, grade 8 learners. Welcome to today's mathematics session. My name is Tuto Masudubele, and I will be doing algebraic expressions with you today. So without any waste of time, let's get into the presentation. Now, the presentation outline, grade 8, is that I'll be doing the introduction, then covering the basic terminology, formulating algebraic expressions, and then we'll be simplifying algebraic expressions as well. And that will lead us to the end of our presentation today. Now, when you notice, in terms of the introduction, grade 8, you might be wondering, why are we being taught algebra at school? Well, algebra, grade 8, is a powerful tool that is used in mathematics to solve many different types of problems. It's a powerful tool, grade 8. So if you are well conversant with algebra, then you will be head and shoulders above the rest. Also, it mainly involves the use of letters of the alphabet in the place of numbers. And we'll get to that just a bit later, where we deal with variables as well when talking about components of an algebraic expression. Now, an algebraic expression, grade 8, is a list of terms involving numbers and variables separated by a plus or a minus. Now, all four basic operations, meaning addition, subtraction, multiplication, and division, are also applied to algebraic expressions. Now let's get a little bit deeper into this concept. Because before we deal with algebraic expressions, you need to understand the basic terminology. It's very important. You need to know what a term means. And by a term, we refer to a combination of numbers and letters of the alphabet involving multiplication and division. Now, terms are separated by a plus or minus, grade 8 learners. So an example of a term is what we have on the right-hand column. 3xy divided by 4. That is a term because it is a combination of numbers and letters of the alphabet involving multiplication and division. Now, what is a variable? You might be wondering, what about this X and what about this Y? Why are we now incorporating letters of the alphabet in mathematics? And the reason why we're doing that is because if we do not know the value of a particular quantity, we need to express that value as an unknown. And what do we use in mathematics? We use variables, letters of the alphabet. So as stated there, it says a variable. It's any letter of the alphabet used to represent an unknown value. Any letter of the alphabet used to represent unknown value. Could be X, Y, Z, A, B, could be T, any letter of your choice. Remember, we use variables to represent what? An unknown value. What about a coefficient? What is it that we speak about when we refer to a coefficient? Well, a coefficient is a number multiplied by a variable. So in other words, if we analyze this particular term here, which is 6k, and we need to know what is the coefficient of k. The coefficient of k will be 6 because it is the number that is being multiplied by the variable. And in other words, you might be wondering, where is the multiplication sign there when you look at the term 6k? So this is actually 6 multiplied by k, and because we write mathematical expressions in a conventional way, we simplify that to 6k. So it simply means there is a multiplication between those two factors. So very important that you understand that. So the coefficient of k will be 6 in this particular example. Now, what is a constant term? A constant term is a number that does not change in an expression. The example is -8. Let me make this example as well. See, now I have 4x plus 9. As an expression. By now, you know terms are separated by what? By a plus or a minus. And what is a term? A term is a combination of numbers and letters involving multiplication and division. So if I were to ask you how many terms do we have in this particular expression that I've written on the screen, we have 2 terms. 4x is 1 term and 9 is another term. So what is the variable in this particular expression? Well, the variable is the letter of the alphabet used to represent an unknown value. So that will be x in this particular instant. What will be the coefficient of x? Coefficient is a number that is multiplied with a variable. So if you look at our expression here, which number is being multiplied with a variable? And that will be 4. That's our coefficient. And what's the constant term? You just learned that a constant is a number that does not change in an expression. So in other words, 9 will be our constant term. In actual fact, positive 9 will be our constant term in this case. Now, getting to the types of expressions that we have a monomial, grade 8s. What a monomial is an expression that contains only one term. So the example I've written down here on the screen has 2 terms. So this does not qualify as a monomial. So in other words, 5y squared will qualify as a monomial because you only have 1 term. So quite important that you understand what we refer to a monomial. Now, a binomial, it's self-explanatory, grade 8. It's an expression that contains 2 terms in this time. So if you have 2 terms, we'll call it a binomial. Remember, mono goes along with 1 and bi goes along with 2. Hence, we have the word bicycle. The word bicycle simply means that you're dealing with an object that has 2 wheels. So remember that. Binomial, 2 terms. So an example would be 6x plus 8. And now what about a trinomial? Think about a tricycle. How many wheels does a tricycle have? It has 3 wheels. So in other words, by referring to a trinomial, we are referring to an expression that contains 3 terms. And an example will be x squared minus x minus 20. Because we have 3 terms. Remember, terms are separated by a plus or a minus. Now let us move on. Now, before we formulate algebraic expressions, we need to know which operation sign goes along with which word in a statement. So in other words, when dealing with the word sum or increase or more than or plus, the correct operation sign will be the addition operation sign. When we're dealing with the word difference or decrease or less than, the correct operation sign that we use in an algebraic expression will be subtract or minus. If you're dealing with the word product or times or of, the correct operation sign will be dealing with there will be our multiplication sign. And when we're dealing with the word quotient, you must know that the correct operation sign that we're dealing with there will be the division operation sign. Now let us proceed, grade 8. Now what we are going to do now that you know which operation sign goes along with which word, we are going to formulate an algebraic expression from a statement. For example, the first one here says the sum. Check the keyword. Notice the keyword, the sum of a number and 8. Now you already know that whenever we're dealing with the word sum, the correct operation sign that will be used will be the addition operation sign. So now it says the sum of a number. Do we know what that number is? No, we do not know. And what do we do in mathematics to represent an unknown quantity? We introduce variables. Variables meaning any letter of the alphabet. So we are trying to find the sum of a number, this unknown number, and 8. Well, 8 is quite explicit. Whatever that number is, we must find the sum of that number and 8. So in other words, what that number is, it could be M or it could be any letter of the alphabet. In other words, it could be X. And what must we do? We must find the sum. So the sum of that number and 8, that will read as X plus 8 or M plus 8. Irrespective of which variable or which letter of the alphabet you use, the statement will still read the same. Now let's get to the next statement. It says double a number and then add 9. So double a number. Well, that's another key word that you should be aware of. What happens when you double anything? Anything that you double, you multiply by 2. So what does it mean? Whatever number it is that whatever quantity it is that I'm going to double, I have to multiply by 2. And then what do? You must also add 9. So what are we doing? We are doubling a number. Do you know what that number is? No, we do not know. What do we do in mathematics? We assign a variable in the form of a letter of the alphabet. So it could be any letter of the alphabet. So whatever letter of the alphabet is, say now you took K as the letter of the alphabet. What do we need to do to the value of K, to this unknown quantity? We double it. And by doubling, you multiply it with 2. Now, what happens if you multiply K with 2? We will get 2K by convention. When we write algebraic expressions, you start a term by writing the numerical coefficient before writing down the variable. Very important. So this will not read off as 2K, as K2, but as 2K. We start with the numerical coefficient before the variable. So in other words, now we have doubled that particular number because we multiplied with 2. Then what must happen? We have to add 9 to that number. And by adding, we know the correct operation sign there. So we'll have 2K plus 9. Same applies in the example we have here. On the column in the right, we have 2x plus 9. But as I said, the variable could be any letter of the alphabet. Now let's get to the next one. What we are doing here by reading the statement is that we need to multiply. Now we need to multiply a number by itself. Now remember, we don't know what the number is. If you don't know what that number is, assign a variable. And what are we doing? We are multiplying that number by itself, so we know the correct operation sign. So if you multiply a number by itself, say now that number you decided it to be variable t. So it will be t multiplied by t because you're multiplying the number by itself. And then what must happen? We have to subtract 16 from that number being multiplied by itself. So in other words, it will be t multiplied by t, or any letter of the alphabet, minus 16, and t multiplied by t. From the laws of exponents, grade 8, you will know that when multiplying powers that have the same base, what you do, you keep your base and you add the exponents. That is why we have t squared minus 16. Where the exponent of 2 comes from, we kept the base and we added the exponents because we are multiplying powers that have the same base. Very important. One thing about mathematics, these topics link with each other. If you know the concepts in exponents, then it will be very easy for you to understand algebra as well. So every topic matters, grade 8 learners. Now the next one says 8 less than a number. Again, we don't know what that number is. Because we don't know what that number is, we assign a variable, and that variable can be any letter of the alphabet. In this case, we chose K. Now, what do we want? We want 8 less than that number. So whatever that number is, we need to subtract 8 because less goes hand in hand with subtract is the correct operation sign that we use. Hence, we have K minus 8 or T minus 8 or X minus 8. Could be any letter of the alphabet. And then the last one, grade 8 learners, in terms of formulating algebraic expressions, it says the square of the quotient of 2 different numbers. Now that particular statement is packed because we're dealing with the square of the quotient. And what did you learn about quotient in the previous slide? Quotient goes hand in hand with which operation sign? And you will remember it goes hand in hand with the division operation sign. So what needs to happen here? We need to divide 2 different numbers. Do we know what those numbers are? No, we do not know. So what do? We assign a variable to represent those unknown values. So it could be x and y, and the quotient of x and y will be x divided by y. So that's by finding the quotient of those 2 different numbers. So it will be x divided by y. So that's the quotient part. What about the square? Remember, when you square, you need to raise the entire expression to the exponent of 2. By doing that, we have squared the quotient of two different numbers. And why did I use two different variables to represent those two different numbers? Because for the very same fact that we're working with two different numbers. If they said they want the square of the quotient of two identical numbers, then it could be x over x all squared. But because we're working with different numbers, we assign different variables. Be careful about that, grade 8 learners. Now let us proceed. Now that we have formulated algebraic expressions, it's time for us to simplify these algebraic expressions. And by simplifying simply means that we make the expression simpler. Now, in order for us to simplify this particular expression, always remember the golden rule of mathematics. And that is what? BOTMAS. It tells you the order in which we apply operation signs. Very important. So now what happens? It means in this particular expression, we need to apply multiplication first before subtraction. Because when you look at the order of operations, multiplication comes before addition and subtraction. So in other words, what do? Y times 9, by now you know that y times 9, we don't write it as y9. No, because when we write an algebraic expression, what we do is that you start with the numerical coefficient. So this has to be written as 9y. Be careful about that, grade 8 learners. Y times 9 will be equal to 9y. So what we have here, this will give us 9y. And then negative 5 times y will give us negative 5y. Now that we have applied the multiplication operation to our two terms, to our factors, what we need to do now is to combine like terms. And what am I referring to when I talk about like terms? Well, like terms are terms that have the same variables and the same exponents. Like terms are terms that have the same variables and the same exponents. So let us look at our expression here. What are we dealing with here? We're dealing with two terms that have the same variable of y, and those two variables, the variable of y has the same exponent. And I'm sure some of you can realize that the exponent of y is 1 for both terms. So we're dealing with what? With like terms. So what we need to do here is to combine our like terms. So 9y minus 5y will give us 4y. So that was the first one in terms of simplifying our algebraic expressions. Now let's move on to the next one here. We also need to simplify this expression. It looks complicated, but it's actually simple if you understand the conventions of writing a mathematical expression, especially algebraic expressions. Remember what I said as well. Not only when you multiply, say now you want to multiply b with 4. That's the simplified expression will be 4b. And again, if you are trying to multiply b with a, instead of saying ba, what you do, you rearrange your factors in alphabetical order. So b multiplied by a will not give us BA by convention. That's not what we prefer as mathematicians. What we prefer, we prefer the expression be written in alphabetical order. So that will be AB. Same applies with y multiplied by x, that will give us xy. So be careful about that as you are writing your mathematical expressions. It must be in alphabetical order. Again, when you're multiplying a variable with a numeric factor, remember the numeric factor comes first, then the variable after. The numeric coefficient first, then the variable after. Just by convention, grade 8 learners. So let us analyze this particular statement. What's happening here, if you check all the terms we have in this algebraic expression, the second term of the expression, if you notice, the variables there are not arranged in alphabetical order. So before we proceed with this particular expression, please make sure that you arrange your terms. So we'll have here 8a squared b minus 4ab squared plus 5 minus 14ab squared plus 15a squared b minus 8. And the reason why we're doing that, so that it makes it easy for us to group all the like terms together. Remember, like terms are terms that have the same variables with the same exponents. So in other words, what's going to happen in this particular expression? We look out for the like terms, and I'm sure you'll realize which term also has terms, also has variables, and the same variables with the same exponents. So if you check which other term has a squared b, and the other term that has a squared b will be 15a squared b. So in other words, we must quickly group those like terms together because they go together. Same variables with the same exponents. So we'll have 8a squared b plus 15a squared b. So what I've done, I've grouped those like terms together. But are they the only like terms? No, they are not. And I'm sure some of you can quickly realize that we do have another term that has ab squared. And what's that other term? That will be negative 14ab squared. Same variables with the same exponents. Very important. So we quickly group those like terms together as well. So negative 4ab squared minus 14ab squared. And then again with the constants as well. Remember, a constant is a term that does not change in value. So in other words, you have constant terms here, and the actually two constant terms, and that's positive 5 and negative 8. So we group those constant terms together as well. So we have here plus 5 minus 8. So again, what did I do in the first procedure? I rearranged the factors of the second term so that they are written in alphabetical order. Second procedure, you group your like terms together. And after grouping your like term together, then you can combine them. This will give us 23a squared b minus 18ab squared minus 3 when you combine all the like terms together. Now let's move on to the next one as well. Now you're trying to find products and a division of algebraic expressions. Now what happens here is that, remember the golden rule of mathematics, BODMAS. BODMAS is our golden rule of mathematics, grade 8 learners. So we have brackets there. So brackets take precedence over the other operation signs. So what does it mean? It means we have to distribute negative 4t into our bracket. So what we'll have 5t minus 12t, multiply negative 4t with negative 2t, that will give us positive 8t squared. I hope you still remember what happened to those bases, the base of t. What happens when you multiply the same base? You keep the base and you add the exponents. And then you multiply negative 4t with 5t squared, and that will give us negative 20t cubed. Because when you multiply in the same bases, you keep the base and you add exponents. And now let's check, do we have any like terms? Yes, we do have like terms. Like terms, terms that have the same variable with the same exponent. And these are our like terms. 5t minus 12t will be our like terms. We quickly combine them. That will give us negative 7t plus 8t squared minus 20t cubed. Again, another convention of writing algebraic expressions is that you need to write your expression in descending exponents of that particular variable, in descending powers of that particular term. So in other words, start with negative 20t cubed plus 8t squared minus 7t, and that will be our final solution. Now let's quickly jump to the second last one. Now we're trying to find the division of algebraic expressions. What happens? Remember golden rule, BODMAS as well. So I think you'll realize that we need to first simplify the expression in our brackets, in the denominator of our fraction. So by simplifying that, by applying the laws of exponents, negative 3 all squared will give us positive 9. because we multiply -3 with -3, giving us +9. And then x exponent 4 raised to the power of 2. What we do, you keep the base and you multiply the exponents from the laws of exponents that you learned earlier this year. So 4 times 2 will give us 8. Now, what do we do with that? It means we need to simplify now. We need to divide the polynomial that's on the numerator with the monomial that's in the denominator. And by doing that, all we need to do is to separate out our terms. So we'll have -36, x exponent 16 divided by 9, x to the power of 8 minus 18, x to the power of 4 over 9, x to the power of 8. And what happens here? -36 divided by 9 will give us -4. Now, what happens now, grade 8, when we are dividing by the same base? You keep the base and you subtract exponents. 16 minus 8 will give us 8. Minus -18 divided by 9 will give us -2. Then you keep the base. You keep your base when dividing by the same base, keep the base and subtract exponents. So 14 minus 8 will give us 6. Now then, let's check. Are these two like terms? No, they are not like terms, because even though they have the same variable, they do not have the same exponents. So in other words, our solution will remain that. That will be the final simplified solution. Now, what about square and cube roots? I'll quickly go to the last one because of time. It's slightly more complicated one. Now we're going to be dealing with square roots and cube roots as well of algebraic expressions. And at the same time dealing with substitution as well. So what we need to do here is to find the square root of 16m to the power of 4 n to the power of 8. What you do, you find the square root of 16 because we are dealing with the square root of one term. Be careful, grade 8. When you're finding the square root or the root, you must be finding either the square or the cube root of one term. You cannot find the square root or the cube root of more than one term. In other words, a polynomial. Make sure that you understand that. So the square root of 16 will give us here 4. The square root of m to the power of 4. What you do, you'll have the 4 divided by 2. Where does the 2 come from? It comes from the square root. Remember, it's called a square root. So it's the inverse operation of a square. And then the square root of n to the power of 8 will be n to the power of 8 divided by 2. So it's simply dividing the exponent of our variables with the inverse operation or the square root function. Minus, now we're dealing with the cube root now. The cube root of 27, you'll know that it's 3. Now what happens when dealing with these variables? Then you simply divide the exponent of that variable with the root. Because we're dealing with the cube root, we divide it by 3. Same applies to the variable n. We'll have here 12 divided by 3. And then we simplify everything. We'll have 4m squared n to the power of 4 minus 3m squared n to the power of 4. Now check the two terms. Are they like terms? And yes, they are, because they contain the same variables that have the same exponents. So we can combine them. So what we'll be left with will be m squared n to the power of 4. And then what the question requires us to do, they want us to find the numerical value if m is 1 and n is -2. So what it simply means, it means we have to substitute in the variables the values that have been given to us. So it simply means we'll have here 1 all squared substituted by -2 to the power of 4, because they told us exactly what the value of m is and what the value of n is. So we substitute into the expression. And when you substitute, remember to include your brackets. Brackets, very, very, very important. Now, as we proceed, this will give us 1, -2 raised to the power of 4. That will give us +16. And 1 multiplied by 16 will give us 16 as our solution. Now, I think that brings us to the end of our session today. It was quite a packed session. I hope you were able to follow at any given time. So with that, we have a quiz, grade 8 learners, on algebraic expressions. It's basically all the concepts that I have presented on in this lesson. It's a 10-mark quiz that you can quickly go through and check whether you understand the concepts thoroughly. And with that, grade 8, thank you for attending our lesson today, and we'll see you next time.